Have you ever wondered what space is really like? Is it a cold and lifeless void, or a vibrant and active place full of surprises? How do planets really orbit the sun, and what makes the Earth appear round from space? Hey there, folks! Welcome to our channel. Here we explore the latest trends and developments in the tech industry, from cutting-edge technology to the latest science discoveries. In this video, we'll break down some of the false realities about space. But before we move forward, don't forget to like the video and subscribe to our channel and tap the notification bell so you won't miss any of our uploads. 1. The Sun, often referred to as a yellow dwarf star, is actually not yellow in color. Instead, it appears greenish-white. The color of a star depends on its temperature and the colors of light it emits. The temperature of a star is determined by the color spectrum it emits. Each color has its own wavelength, and astronomers measure those wavelengths to tell how hot a star is. Cooler stars appear red, while the hottest stars look blue. Our sun emits most of its energy at a wavelength that's close to green, which is why it appears greenish-white. However, the sun's true color is not visible to us on Earth because of our atmosphere. The Earth's atmosphere is good at scattering blue light, which means that when we look at the sun, we see it as yellow. This is because the blue wavelengths of light are scattered away, leaving only the other colors to combine into yellow. But if we were to view the sun from the International Space Station, where there is no atmosphere to scatter the light, we would see its true greenish-white color. If the sun were actually yellow, it would be about 800 degrees Celsius cooler than it is now. This would cause the habitable zone of our solar system to shrink, and Earth would become a frozen, lifeless rock. So, if the sun were not its actual greenish-white color, life on Earth as we know it may not exist. Therefore, it's important to understand the true nature of the sun and the impact its color has on our planet. 2. While the sun may appear to be on fire due to its intense brightness and heat, it is not actually burning in the traditional sense. When we think of burning, we typically imagine a chemical reaction between oxygen and some sort of fuel. However, the sun is a massive ball of gas, mostly made up of hydrogen and helium, with very little oxygen. Instead, the sun generates its heat and light through a process known as nuclear fusion. In the core of the sun, temperatures reach upwards of 15 million degrees Celsius. Under these extreme conditions, hydrogen atoms are fused together to form helium. This process is called nuclear fusion, and it releases a tremendous amount of energy in the form of light and heat. In fact, the energy released by the sun's fusion reactions is responsible for sustaining all life on Earth. 3. The idea of explosions in space is a common misconception perpetuated by movies and television shows. In reality, explosions in space do not occur in the way we typically think of them. This is because explosions require three things: fuel, heat, and oxygen. While fuel and heat can be present in space, there is no oxygen present to allow for a traditional explosion to take place. The absence of oxygen in space is due to the vacuum-like conditions that exist beyond Earth's atmosphere. A vacuum is a space with no matter, including gases such as oxygen, so there is no air for an explosion to propagate through. Therefore, a spaceship cannot burst into flames or explode as we see in the movies because there is no oxygen present to sustain a fire. 4. There may seem to be too many stars in the night sky for you to count, but actually, you can. Although scientists at Harvard have already done it for you. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the naked eye. Try to count them all for yourself. 5. The asteroid belt has long been depicted in movies and science fiction as a dangerous obstacle course that requires expert piloting skills to navigate. However, this depiction is far from accurate. While the asteroid belt does contain trillions of space rocks that range in size from dust particles to the size of small moons, the vast majority of these objects are very widely spaced apart from each other. The asteroid belt is located between the orbits of Mars and Jupiter and spans an incredible 225 million kilometers. This distance is 1.5 times the distance between the Earth and the Sun. Due to the immense size of this area, the space rocks within it are spread out over millions of kilometers, making it almost impossible for a spacecraft to collide with one. 6. The idea of being thrown out of an airlock into the vastness of space is a terrifying thought, and one that has been portrayed in many science fiction movies and TV shows. While the reality of the situation is not quite as dramatic as the movies make it seem, the dangers of being exposed to the vacuum of space are very real. One common misconception is that a person would instantly freeze in the vacuum of space. However, this is not entirely accurate. In space, there is no matter to conduct heat away from the body, so the only way for heat to be transferred is through radiation. Radiation does not transfer heat very efficiently, so the process of freezing would be much slower than many people assume. In fact, it would take several hours for a person to freeze to death in space. However, this doesn't mean that being exposed to the vacuum of space would be survivable. The lack of oxygen and atmospheric pressure would cause the lungs to decompress, leading to rapid tissue damage and death. Additionally, the extreme cold and radiation exposure would cause other serious injuries to the body, including damage to the skin, eyes, and other organs. 7. When people think of space, they often imagine an incredibly cold and inhospitable environment. However, the reality is a bit more complex than this popular misconception. In fact, space itself does not have a temperature at all. Temperature is defined by the motion of particles and the amount of energy they possess. In a true vacuum, there are no particles present to move around, and thus no temperature can be measured. However, space is not a perfect vacuum. There are still particles and radiation present that can produce heat. For example, the areas of space surrounding stars can be incredibly hot due to the intense radiation and energy produced by these massive celestial objects. However, as you move further away from stars, the particles in space become more spread out, leading to cooler temperatures in these areas. 8. While it may seem like our solar system is stationary, it is actually hurtling through space at an astonishing speed. The solar system is traveling at a rate of 220 kilometers per s, which is roughly 7 times faster than Earth's speed around the Sun. This means that, even as we go about our daily lives, we are hurtling through space at a mind-boggling speed. But our motion through space is not aimless. Our solar system is orbiting around the center of the Milky Way galaxy, which is located about 25,000 light-years away from us. It takes our solar system approximately 230 million years to complete one orbit around the center of the Milky Way. This means that since the birth of our solar system, we have completed approximately 20 orbits around the Milky Way. The last time we were in the same position we are now, the Earth was home to a supercontinent known as Pangaea, and the first dinosaurs were just beginning to roam the planet. 9. When we think about the way planets orbit the Sun, we might imagine them traveling in neat circles around a central point. However, the reality of planetary motion is far more complex than this. In fact, planets and other objects in our solar system are constantly being influenced by the gravitational pull of other celestial bodies. As a result, the motion of planets is not simply an orbit around the Sun, but rather a dance in which all the objects in our solar system are participating. This dance is controlled by the barycenter, which is a point in space where the mass of all the objects in the system is balanced. The barycenter is the point around which 2 or more celestial bodies orbit, and it is determined by the combined mass and gravitational pull of all the objects in the system. For example, the barycenter of our solar system is located very close to the center of the Sun, because the Sun's mass is so much greater than that of all the other planets and objects in the system. 10. While Earth may appear round from space, it is actually an irregularly shaped ellipsoid. This means that the shape of the planet is not a perfect sphere, but is instead slightly flattened at the poles and bulging at the equator. This is due to the centrifugal force caused by the Earth's rotation. As the Earth rotates, the centrifugal force causes the planet to bulge at the equator, making it wider than it is at the poles. This bulge is not noticeable from the surface of the Earth, but it is easily visible from space. The difference in diameter between the equator and the poles is about 43 kilometers. This difference in shape also affects the Earth's gravitational field. Because the Earth is slightly flattened at the poles, the gravitational force at the poles is slightly stronger than it is at the equator. This means that objects weigh slightly more at the poles than they do at the equator. Conversely, the weaker gravity at the equator makes it easier to launch spacecraft from this region. This is because launching a spacecraft requires a significant amount of energy to escape the Earth's gravitational pull. The weaker gravitational force at the equator means that less energy is required to launch a spacecraft from this region than it would be from the poles. As a result, many launch sites are located near the equator, such as Cape Canaveral in Florida, which is located at 28 degrees north latitude. This location was chosen specifically because it is close to the equator, which makes it easier and more efficient to launch spacecraft into orbit. So what did you think about the realities of space? Did you learn something new about our universe that surprised you? How do you think our understanding of space will evolve in the future? Let us know in the comments section below. Thanks for watching. Don't forget to like, subscribe, and hit the notification bell to stay up to date with our latest content. We appreciate your support and look forward to seeing you in the next video.